All right, so far the approach that we've taken was this. We did yc plus yp. Now I'll talk about a problem that I haven't exposed you just yet. Okay, so let's say that I am trying to find yp terms, right, based on what we talked about in terms of our forms that the yp should be in, and let's say that the terms that we have for yp that is also present in yc. Okay, let's say that we solve it and we find that yc is equal to, let's say, c1e to the x, right? I'm making this up. And then when you make a guess for the yp, if you try to solve this with e to the power of x, okay, you see that they're the same, you will have a problem. You will have a problem. What I mean by you will problem is, as I will demonstrate soon, you will see that the left-hand side of the equation will be 0 and the right-hand side you'll be left with something, okay? Because then when I put e of x to the left-hand side of the equation, as that is a solution, it will get a 0, right? But in the right-hand side will be g of x. So yeah, this is a problem for this particular approach that we have established. Okay, we analyze that there's a problem. Well, that's not good enough. We need to introduce a solution. Yes, we have a solution. And the solution is this. xp must be multiplied by x to the power of n, and lowest possible value that makes yp different than yc. Okay. Again, so far you may not be appreciating what's going on over here. So the best thing is to go with a simple example to illustrate what I'm talking about over here. Okay, so let's do that. Let's go ahead and try to solve this particular problem. Y double prime minus 2y prime plus y is equal to e to the power of x. I choose this on purpose so I can kind of make comparisons here. All right, good. So what I will do is I will look at the homogeneous equation first, because y is equal to yc plus yp. So I need to find my complementary solution. So y double prime minus 2y prime plus y is equal to 0. If I write the ancillary equation, m squared minus 2m plus 1 is equal to 0. And you can see this is m minus 1 square, isn't it? Is equal to 0. So I get a double root right there, which is 1, right? I did it a little bit fast, so hopefully you were able to catch up. So then if I look at the yc, how it should be formed, as we discussed before, it will be c1e to the power of x plus c2x e to the x, right? Okay, good. So there's nothing, we don't have a problem so far. Now here's the problem. I am looking at the yc is being established, so let's look at the yp. So according to the process that we have established, I have to try e to the power of x. So now, as I mentioned over here, you can try this at home. If I plug this, basically c1 and a is just basically two arbitrary constants. So basically I'm talking about this solution. So when I plug this over here, as this was a solution, right? Basically that's how I obtain it. I'm gonna get myself 0, right? So the left hand side of this equation will be 0 and the right hand side will be e to the x. So you will be really panicking right there and then, okay? So the approach that we have introduced, if I go back slightly up, is I'm gonna multiply by x to the power of n, and n is as small as possible, okay? So in this particular case, let's say that I multiply this by x. What will happen is I'll get a x e to the x, but unfortunately it also appears over here. So then I have to go to the n is equal to 2, which is ax squared e to the x. Okay, so that's what I had to try. So then my yp, this time around, the form that I'm going to have is going to look like this. So let me go ahead and proceed with the steps. Yp prime will be equal to, a little bit more complicated than before. So chain rule. 2ax e to the x plus ax squared e to the x. Not too bad. Let's do yp double prime. So it's going to be, again, another chain rule. 2ax e to the x, I'm taking it to say x, plus 2a e to the x, right? The second one is going to be 2a x e to the x plus ax squared e to the x. So let me see whether there's something that is summing up. Yeah. Let's look at these two terms. So I get myself yp prime double prime is equal to 2a e to the x plus 4a x e to the x plus a x squared e to the x. So then go ahead and insert this into my main equation, which was y double prime minus 2y prime plus y is equal to e to the x. Okay, so obviously these will be p for this particular case that we are analyzing. Okay, yp double prime, let's write this from x squared on the order like this, plus 4ax e to the x plus 2a e to the x, right? I think I did a decent job there. Minus 2 times 2ax e to the x plus a x squared e to the x. Okay, what's left is what my yp was, which was ax e to the x squared, right? Ax squared e to the x, and the right hand side will be e to the x. So I have myself a bunch of terms with e to the x to the power e to the x squared, right? So that's the highest order that I see. So let me take with respect to that. So I'll have this one, a here, minus 2a plus a. That is 0 right there, right? Okay, I'm doing this drag to collect, but it has to, otherwise we made a mistake, okay? Well, anyways, let's proceed. Then I'm gonna have e to the power of x times x, right? So then I have to have myself 4a, right there, then minus 4a, okay? Again, let me do my geometric collect again. It is 0, wow. Well, it has to be, right? Let's be honest. Look at the right hand side, I don't have any term with x. Let's now continue. Plus, then I'm only left with, well, this one, right? 2a e to the x is equal to, right hand side is e to the x. So you can see from here is a is 1/2, right? So I get myself yp is equal to x squared by 2 e to the x, right? Then if I finalize my yc plus yp, e to the x plus c2x e to the x plus x squared by 2 e to the x. So I can take with e to the x parentheses, one more step, y will be equal to e to the x c1 plus e to x plus x squared by 2. This will be my yc plus yp for this particular case, okay? Alright, let's go ahead and solve this particular question. Now this is a higher order than second, right? Third order differential equation. So again, it doesn't make my process different. So I'll have the complementary solution plus the particular solution. Complementary solution will be obtained by having an homogeneous equation is equal to 0. That's what the homogeneous means. In the ancillary form, I will get myself this. And you can clearly say I can take out m squared, right? M plus 1 is equal to 0. So I have m is equal to minus 1. M2 and 3 are 0. It's a double root. So if I go ahead and write my yc, that will be, well, let's start with the zeros. c1 e to the 0x plus c2x e to the 0x plus c3 e to the minus x. So you can see in here this is 1, this is 1. So let's write it one more time. yc will be equal to c1 plus c2x plus c3 e to the minus x. Okay, so far so good, which was the easier part of the solution steps. The next thing is looking at my basically yp, right? And now I have to consider g of x, which is e to the x cosine of x. So looking at the form that yp should be in, this is going to be a e to the x cosine x plus b e to the x sine of x. Again, I mentioned this before as well, but do not ignore this part, okay? Just because it's a cosine, you can't just simply go ahead and write cosine. You have to have sine as well, because the derivatives, the second and the third order derivatives will include the derivative of cosine as a minus sine, right? So, okay. So then what I have to do is I have to find the first, actually if I go up before I do that, here, right? So I need to find the second derivative of that. So I have to be a little bit more creative. So let's take a look at it. It shouldn't be too bad. Yp prime. The only thing is I see a chain rule that needs to be applied over here, right? So let's do with respect to the cosine first. So that's going to be minus a e to the x sine x. You know this very, very well, but just to repeat, the derivative of cosine of x is minus sine x, and the derivative of sine x is plus cosine of x. Okay, I simply use that. And the derivative of e to the x is, well, itself, just like I said, plus b e to the x sine x plus b e to the x cosine x. And if I, you can see that I can combine two terms. I see here sine x, so you can see b minus a e to the x sine x plus, same logic I have here and here, right? Cosines can be combined, so I get myself a plus b e to the x cosine of x. I'm doing this simplification because I will have to go at a bit, actually two more order of differentiation. So then let's do the same step, b to b minus a e to the x sine x. I took the derivative with respect to e to the x first. Then I will have b minus a e to the x cosine of fx plus a plus b e to the x cosine of x. I took with respect to e to the x minus, because cosine, derivative of cosine is minus sine, a plus b e to the x sine x. So now let me do this. There's a lot going on in here, so let's do this. E to the x cosine of x. Let's see what's going on. So I have b minus a plus a plus b, right? That's what I have. How about e to the x sine x? I have b minus a, and the last term is minus a minus b. Don't forget the minuses. So then I get myself, you can see in here these two cancel. You can see in here these two cancel. I get myself 2b e to the x cosine of x minus 2a e to the x sine of x. Am I done? Yeah, if this was second order, yeah, but it's not. It's a third order, right? I see the third order, so I have to do one more derivative. It's becoming a long question. So 2b e to the x cosine x minus 2b e to the x sine x. So this is for the first term. Minus 2a e to the x sine x minus 2a e to the x cosine of x. So if I combine them, it will be e to the x cosine of x 2b minus 2a, right? So from here, cosine of x plus e to the x sine of x. You can see both terms are negative, 2b minus 2a. So that's kind of it, right? Phi p prime. Now what I have to do is I have to go back and insert this into the equation. Insert into this yp triple prime plus y double prime will be equal to e to the x cosine of x. So yp triple prime is right over there, so I'm going to write this e to the x cosine of x 2b minus 2a plus e to the x sine of x minus 2b minus 2a. So far so good. So this is for triple. How about the double? Double is actually in there as well. It's going to be 2b e to the x cosine of x minus 2a e to the x sine of x. That's the left hand side. And the right hand side is equal to e to the x cosine of x. So I can simply go ahead and combine things like this. E to the x cosine of x of 2b minus 2a plus 2b, right? Basically, I accounted for these two terms. Plus e to the x sine x of minus 2b minus 2a minus 2a, right? Is equal to basically this. So if I simply rewrite this, you're going to see e to the x cosine of x. That's going to be 4b minus 2a plus e to the x sine of x minus 2b minus 4a will be equal to e to the x cosine of x with a multiplication of 1. So from here you can clearly see 4b minus 2a is equal to 1 and minus 2b minus 4a is equal to 0. So from here you can see that 2b is equal to minus 4a. So b is equal to minus 2a, right? That's what I get. So if I pick this up and plug over here, you're going to get 4b is minus 4a minus 2a is equal to 1. So from here I get myself a is equal to minus 1 by 10, right? 10 minus a is equal to 1. Okay, so let's actually make this a little bit better. Minus, so then b will be twice of it, so it's going to be 2 by 10 or 1 by 5, right? So then my particular solution turns out to be minus 1/10 of e to the x cosine of x plus 1/5 of e to the x sine of x, right? Then if I combine y, which will be yc plus yp, then it will be, I remember, c1 plus c2x plus c3 e to the minus x minus 1/10 e to the x cosine x plus 1/5 e to the x sine of x. So that's gonna do it for this particular problem, right? Thank you for watching this.